Hello everyone. So in this video we will see the application of second order system that we have learned in the previous video. So here you have to draw the here you just need to analyze the circuit. You just need to tell the output waveform and everything. Okay. So first tell me what is the output voltage at t equals to 0 plus. Shorted 0, and at t equals to infinity open circuited again 0. There would be no current, so again 0. So now how will your output look like? From V naught t like this, 0 to 0 like this? No, because it's not zero order or first order system, it's second order system. Why? Because it is having two poles. How can you tell it is having two poles? Just so circuit this input, then your circuit would look something like this, right? Your circuit would look something like this. So the current flowing through this capacitor and current flowing through this capacitor both are different, right? And current flowing through this resistor and this resistor both are different. So all of them are having different currents, and you have two storing element here, so it's a second order system. So you have two poles. You can't really tell where the poles would be, but you can tell one thing: both of the poles can't be imaginary, right? You can't really have the imaginary poles here, so it can't be underdamped or undamped because the poles won't be imaginary. Okay, so there are two conditions left: critically damped and over damped. In critically damped we have two poles both at same point, and in over damped we have two poles both at different point. So again you can see here that both of the poles won't be at same point, right? At 1 by RC or anything like that, both of the poles won't be at same point, but they will be at different points. So it's definitely an over damped system, right? But now how does the over damped system look like? For second order system, for step response, the over damped system would look something like this, right? It's going from 0 to a certain value, but it should come from 0, it should go from 0 to again 0. Like first we have understood it's an over damped system, and for over damped system this is how the response look like. But I have told you one more thing, like if you are having a 0 at 0, s square plus 2 zeta omega ns plus omega n square, if you are having a 0 at 0, then your step response would look like the impulse response of second order system. If your transfer function has a 0 at 0, 0 at 0, then your step response would look like impulse response of the second order system. Okay, and then how does the impulse response look like? In the previous video I have explained all this concept. So impulse response would look something like this. First it go from here to here. Okay, so from 0 it's coming down to 0 only, but it goes to a certain value very fastly and comes down to 0. That's how the response look like. Okay, so that's a nice question. So firstly they would ask 0 this response, then they would say what is the damping here? It's over damped system. You can explain both of the poles are at different point, and then they will tell you to make the graph. Then you can't really say like it's an step response and then it would go something like this. No, it shouldn't go something like this. It would go something like this, because in reality it is acting as a impulse response of second order system. Why is it so? I have explained in previous video. You can see that. Okay. Now coming to this one. Now here what you can see, at V0 plus you are having V in voltage, and at V0 infinity also you are having, at V0 infinity open circuited, so it would be V in only. So your response will go something like this? No. Why? Because it's an second order system. So how does how will it look like? Like this you have V, and again at steady state you will have V only. But what you can notice here is you are having two zeros here. For finding the 0 you can say like, oh, I forgot to explain why we are having a 0 at 0 only. Here I have explained why we are having here I didn't explain why we are having 0 at 0. So for finding the 0 you can simply make the output to be 0, and for making the output to be 0 you can have infinite frequency here, because at infinite frequency it would provide 0 impedance, so you will have a 0 here. So at infinite you can have, but this won't count. But you can make this one as infinity as well, like your transfer function of Z2 upon Z2 plus Z1. That's how your transfer function look like. So if you make Z1 to be infinity, your V0 by Vin would be 0 only. So if you make Z1 infinity, then it would be fine. And where you can make Z1 infinity, R by R plus 1 upon CS. If you make if you take at 0 frequency, it would give you infinite impedance. So you are having a 0 at 0. Okay, that I forgot to explain. So you are having a 0 at 0 only, but here you are having 0 at 1 by RC, and that two times. Okay, just see, at 1 by RC, it would give you 0 value, right? This value, this complete Z2 resistance would be 0 at 1 by RC, right? One, just put R plus 1 by CS equals to 0, so S would be 1 by RC, and this would also give you infinite at 1 by RC, yeah, because it would be something like this, R plus 1 by CS. So if you put 1 by RC here, if you make this one 0, then it would give you infinite impedance. So at 1 by RC only you are having two zeros. So your transformation is something like this: RCS plus 1 square. You can have some DC value here, A, let us assume, and you will be having, this is a second order system. You can again see, because the current through this capacitor and this capacitor wouldn't be same if you short circuit this input. So it's an second order system. So your response would be something like this: S square plus 2 zeta omega ns plus omega n square, and there you have some DC value. So this is how your response would look like. So here you have two zeros and two poles. So you can't really tell intuitively how the response looks like. Okay, you can tell like it would go from, like you can tell one thing, like it's an overdamped system, right? Overdamped system you can tell, because the same condition, like it will have two different poles, that two real, like there wouldn't be any imaginary poles. Real pole would be there, and that two on real axis, and that two different, not the same. Okay, so you can tell it's an overdamped system. One thing you can also tell that your output value will never go above V voltage, right? It will never go above V voltage, because this V is charging these two capacitors, so it can never go above V voltage. So it has to go down only. So it will go down and again come back to V. This is how the response will look like. So intuitively you can tell in this manner only, like it would go immediately go down and immediately go up. Like this is how the response look like, and I also simulated it in MATLAB. So that's how the response look like. Okay, goes down and then comes back. Okay, so you can't really say like it's an impulse response or step response or anything like that, because you are having 2 0 here at 1 by RC. So you can't really comment on that like this, but you can say like this is how the response would look like. Okay, so if they ask you these kind of questions, what you will see, you will just see the value at 0 and infinity. Then you will say like it's an second order system or first order system. Then you will tell them damping. You will tell them the region, like it's like these two circuits are having two poles, both at different points. Then you will tell them damping. Then you will say it as, then you will point out the 0 location. You will say it's having a 0 at 0. So you will write the transformation and then draw this waveform. So you can also tell like this is acting as a impulse response of second order system with no 0. Okay, because V by S would make it look like impulse response, that I have explained in previous video. And in this one you can also tell like it is having two zeros at 1 by RC and two poles at some different points. So it's an overdamped system, and we can't really comment on the nature, because it's not a standard like what we can say, like it's not a standard expression. So but what we can say is like it can never go above V voltage, so it should go something like this. So from V it would go down to 0 and then reaches to V only. So that's how the response look like. So you can comment on these kind of circuits like this. So these are very less discussed. I haven't seen any video regarding this. So that's how you should approach this kind of question. And before watching this, I am really recommended to watch the previous video. Okay, so then only you can understand these concepts. Okay, so these are very, very important concepts, I must say. Okay, so I have two more circuits that I will deal in next video. Okay, thank you.